Hi, in this video we will talk about list, set, maps and big maps. The first thing to know in Ligo is that there are no classes or encapsulation. So what we use library and function on it to modify the Michelson types. The second thing is that memory is very expensive on the blockchain. So when you will load a smart contract into memory, all this type will be loaded in the memory, and this costs a lot. That's why we will see big maps at the end as an alternative to save a lot of cost. The first type is a list. A list is a sequence of items and they can be duplicated. Let's see an example how to create an empty list. See how do you initialize this list. Now let's see how to add an item to this list. So to add an item to a list, you just concatenate a header with the rest of the copy of another list. To remove an item, you don't have a remove function, so you will have to use another way. So to remove some elements on the list, you can do a comparison and use filter map to extract the element that you don't want and just keep the one that you want. Let's see how to get the size or the length of the list. Okay, so finding an element in the list is using the function find optional, and will return an optional because we don't know if this element exists or not in the list. To extract an element on the list is a little bit tricky. We don't have an index or a position to be able to extract it. So the way to extract an element on the list is to extract the header, but if your list is empty, it will return none. To return or extract the tail of a list, let's see how to do that. In Ligo, it is quite unusual to extract items one by one. What you will do normally is to loop over it. There are three ways to loop. Let's see each of one: iter, map, and fold operations. So the first way is to use the function iter, but you return a unit. So what you can do with that is doing just assertion and raise exceptions. No more than this. Second way to loop is to use map, and map will modify as elements of the list. So with a map, I will loop over each element and I will apply a function to modify this element. It will return a new object that we know we never update a reference to the object displayed by copy. I remember in the function we always pass by copy. So it will just modify some elements and return a new list here that is modified by my function increment. The last way to loop over a list, for example, is to use fold, and we will use an accumulator. It works like a reducer. So here when I use list.fold, I will pass my function of reduction. The second argument is the list I will iterate over. And the last one is initialization of the accumulator. That will be my end result. Okay, so the second type we are going to see now is the set. It's pretty similar to the list one, except it doesn't accept duplicated elements. To create an empty set, let's see this example. So to initialize a set, you use set.literal and you pass a list in the parameters. Here, because it is a set, even if you have duplicated element in your list, at the end we will have only one reference of, for example, the value 2. To add an element on the set is pretty easy. To extract or remove an element is also very easy. To get the size, you use the function size. To find if an element exists on the list, you can use the function mem. Okay, you don't really need to extract an element on the list. You can just try to loop over it and return a new set, for example. So it is the same like for a list. We will see how to loop using iter and fold. Okay, now let's see the type map. So you know map is a key value store and is loading into memory. Let's see how to create an empty map first. So to initialize a map, you use map.literal and you pass a list to the parameters. And inside of the list, you have pairs of elements that will compose all the key values, so the entries of your map. To add an element on the map is pretty easy. So to add an element, you use map.add. You add the key and the value. So to remove an element, you just use map.remove. Now to get the size of the map, you use map.size. To find an element in the map, you can use map.mem. To get the value from a key, you use map.findOptional. Returns an optional because you don't know if the key exists and the value. So to loop over a map, you have again 3 choices. Use iter, map, or fold functions. There are 2 additional functions for the map. It is the function to update and another function that is called get an update. Let's see these 2 functions now. So in map.update, the first argument is a key where you want to change the value. The second argument is a new value, and the last argument is a list where you want to find this element. It always returns a new map. Now the other function is get an update. The difference is that get an update will extract the key value and will return you the value extracted from the map, and you can pass as a second argument either the new value for this key or just none to remove in fact the key value from your map. This last function is very important for the usage of tickets, for example. So tickets, they are specific objects that are unique on the blockchain. You cannot copy this object. You cannot copy a ticket and duplicate its value. So here, when you want to update a ticket, you extract it from a list or a map here, for example, and then you change the value of the ticket and you put it back to the map. Loading Michelson types in memory can be very costly. So to tackle that, we have another object called BigMap. And BigMap is a kind of a lazy loaded map. It doesn't load into memory the full map, and you have to access to the elements by the keys. So the same way as a map, we can also initialize with some values. Now let's see how to add and remove elements on the BigMap. Now can you get the size of the BigMap? No, it's not possible because it's lazy loaded. So you cannot have a function to get the size of your BigMap. But what you can do, you can store, for example, the keys of your BigMap somewhere and look on this list of the keys, what is the size of the list, and then you get the size of the BigMap. To find an element on the BigMap, you need to access to a key. So it's the same like for a map, you use the function mem. To find an element inside of a BigMap, you use BigMap.findOptional. Now can we loop over a BigMap? Well, the answer is no, not really, because you don't have the full collection that is on the memory. Well, what you can do is like having a list of the keys and then iterate on the keys and extract the value one by one. But you have a way to update a BigMap. Let's see how to use BigMap.update. Okay, so the same way for maps, you have update and get an update. You have the same from the BigMaps. Thank you for watching and see you next time.